Hey everyone, welcome to the first activity in the orangutan-stem product series. I'm Mike, and in this video, I'll walk you through setting up a local and server-side Apache Airflow environment using Docker. We're also going to explore cloud tools in AWS and GCP and learn how to fetch weather data from a free weather API and stitch everything together as a data pipeline. So this is my first activity walkthrough, and I will go ahead and briefly introduce myself and give you a little bit of background around the project. The video will probably start in terms of the code walkthrough around minute 2, so I'll put some time thresholds around the video. My name is Mike. I've worked in the data industry now for about 8 years. Worked a lot of different roles in my career, data analyst, data scientist, data engineer, and am currently an engineering manager at an unattended retail tech company. About 4 years ago, I started this project as an alternative to grad school. I really wanted to find something that was able to blend my passions while at the same time learning valuable skills in data and software engineering. Around the same time 4 years ago, I got to do this really incredible orangutan trekking experience in Sumatra, Indonesia. After the trip, decided to team up with the local trekking company owner, and together we founded a farm. The goal of the farm was to build and host agricultural data systems, and this series unveils the process of constructing these data pipelines. So this is aimed at helping any aspiring data professional who have some familiarity with Python and SQL. My mission is to enhance your skill sets and give you a taste of the tools used by data and software engineers in the real business world, as well as on our farm in Sumatra. I developed this code base so I can master it and effectively share it with students, professionals, and anyone curious worldwide. We'll mainly be focusing on agricultural data systems, but the beauty of the code base is it's very flexible and you can adapt it to your own projects. So if you're ready to dive in, let's get started. All right, let's get started. So the first thing we're going to want to do is open up the public repo for orangutan-stem on GitHub. So to do that, you'll just open up an internet browser and type github.com/mikestack15/orangutan-stem. I will put a link to the URL in the video description below, as well as a clickable link in the video right here. So once I go here, I will be redirected to the GitHub page that contains our repo. This is public, so everybody should have access to it all around the world, no matter where you are. Our README basically covers, the goal of the orangutan-stem project, its focus, some prerequisite skills. Probably helpful to have some intermediate Python and basic SQL skills. A lot of the activities uses them both fairly extensively, so just a little bit of comfortability or a little bit of background in both of those languages will take you far in this project, and no fear of failing. So all the activities are listed right here. Once they are available, you'll see the clickable link, and our getting started basically has a table of contents which shows all the wikis that we've written so far and their clickable URL, as well as a learning resources wiki. So if you are new, this is a great place to get started. Anybody can learn how to code, anyone can learn Python, anyone can learn general computer science. You don't need a degree in it, you just need to have passion and discipline. So don't be afraid, and always keep practicing. It's never a good thing to ever stop learning. So the requirements wiki, this is fairly important. Make sure to set up your AWS and GCP accounts. We use both of them fairly extensively in all of the activities, including this activity 1 weather data pipeline that we'll be building. You'll also want to make sure you have Docker and Docker Compose installed. There's a link to install the Docker desktop. It has an installer for Windows, Mac, and I believe Linux desktop, so it's fairly simple, and Docker Compose comes out of the box with that installer, so you can check that everything works with these commands right here. And the most important thing is for this activity is the Open Weather Map API. You're going to need to create an Open Weather Map account and generate a key for it in order to hit their API and return a response. So creating it's fairly simple. There's a link on how to do that here. You'll just basically create your account, and then once you're signed in, you'll go to this API key section and then create a key. And yeah, it's pretty straightforward. So without further ado, we'll go ahead and get into the activity 1 wiki here. Again, this is just all on the README page, so you could just click it as soon as you visit the orangutan-stem repo. Tools used: Python, Docker, Apache Airflow, AWS S3, EC2, Route53, GCP, we're using Google Cloud Storage, BigQuery, and then Ubuntu as our Linux server on EC2. So again, be sure to set up your AWS and GCP accounts. We do use GCP service account as well as the AWS access key and secret access key, so you'll want to make sure to get those set up. So the objective for this activity is we're going to be trying to set up our local environment, our Linux server, and utilize a lot of cloud services around this repo. This repo is really nice because you can clone the repo and run a couple of commands, and it should work locally on your machine relatively easily. So it's a really good activity because it exposes you to a lot of tools that data engineers and software engineers use in this field. So I think it ties together a lot of different systems and infrastructure that you would use in a full-time role as a data engineer or software engineer. So to get started, make sure, again, create your open weather map API. This can sometimes take hours to do, so be patient with it. If you're just starting the activity now for the first time, the first thing you should be doing right now is creating your open weather map account and then generating an API key. I have a code snippet right here to test that your API key is working. So, to do this, you can basically just open a local IDE of your choice. It could be PyCharm, it could be VS Code, and you can just copy and paste this code. I have a sample Latin long for Pahoric, Northern Sumatra, as well as my current address for Chicago, Illinois. Not exact current address, but city address for the Latin long, and then you would basically put your API key that you generate in the Open Weather Map API in this line between the single quotes here, and this will print out the response. And if you get a successful response printed, that means your API key is active. So Python 3.11.5 is probably the best version to install as of a few days ago. You can just go to this Python installer download site. Fairly simple. They, just like Docker, it has an installer, so pretty straightforward. For the Docker side, the installer is basically in the requirements wiki here. You can just click this link here for downloading Docker Desktop, and then make sure if you have a MacBook like me with an M1 or M2 chip, you click Apple chip. But if you're just on Windows or Linux desktop, it's fairly easy to just click the button and then the installer automatically starts installing. To make sure that we do have Docker, we can just open up our command line here or terminal, and we can run this command docker -- version, and it should print the Docker version that we are using. We could also check that Docker Compose was included in the installer, so I can just run docker -compose space -- version, and then we see that we have the a more recent version of Docker Compose. So another Docker command you can just test for fun is docker -ps. This basically just shows you all the containers that you have running right now. So I have a few containers up that is running this image from the code base that we have cloned, and I will show you that here shortly. So VS Code, I'll be using VS Code for a lot of the activities. I like VS Code a lot. I love PyCharm as well. I use them both pretty interchangeably, but I do recommend downloading VS Code. There are some very particular tasks that VS Code excels over Python or PyCharm in. So just good to have an extra tool to use whenever you have to do mundane file modifications and you don't want to use Vim or Nano. VS Code is fairly nice. So obviously you'll want to have Git. A lot of machines come with Git just right out of the box, but if you don't, you want to go to the Git website, the website where you can download Git in the latest release, just like everything else here. For the desktop version, they have installers, so it's as easy as just clicking one of these links, and then to actually verify that Git was properly installed, you can type just git -- version or just git -v. Both should work, or one or the other should work. And one thing I kind of brushed over is Python 3.7, I believe, is what's used in the current Docker image on the Docker Hub Airflow image. So obviously Python 3.11 is out, and it's probably better to have a newer and better version of Python locally. So I just recommend installing Python. So on a Mac, you have to actually type Python 3 -- version, but on Windows, you would just type Python without the 3, and it will print out whatever version you have. So I have one update I have to do, which I will do this weekend when I have some time. So everything's looking good. We want to make sure we have Python, Docker, VS Code, and Git. I have all of these, and I have checked them, so I think we are good to go. I will quickly show you what this pipeline does. So I'll first go to my local host 8080. This is where the web server for Airflow is pointed to in the local Docker deployment that we will be going through here. So I have a DAG called extract open weather data to lake. This basically runs 3 different tasks. Essentially, task 1 is to extract the API response from the Open Weather Map API. Then it's to load it into S3 into a specific S3 directory path, and then from there basically load it from S3 into Google Cloud Storage and then into BigQuery. So if I trigger this DAG right now, what's going to happen is we could see it'll start running. It runs fairly quickly, usually under 10 seconds. The last task I think is usually the longest one, but this all ran in 3 seconds. And if I were to go into AWS S3, logging in first, I could see, hopefully, now for my most recent run, that our raw ingested main weather content.json object was ingested. I just ran this a few seconds ago, so this is actually the most recent time. If I then go into GCP, and then if I go into Google Cloud Storage, I should see the same JSON saved in the same file path directory. This file path directory is available in the DAG code itself if you want to see how it's set up, but I should see a JSON object just as I did in S3 right here with a more recent time of when it was run, which was just a few minutes ago. And then if I were to go into BigQuery, on the GCP side, there's a data set called Bucket-Lawang weather, and then a table under it called raw ingested made weather content. I should see that data was also recently updated, and I should see some data in the preview itself. So this is how this DAG works. Pretty straightforward DAG. We're just taking data from a API request that we're using Open Weather Map API for, loading it into S3, and then from S3 loading it into Google Cloud Storage, and then ultimately into BigQuery. So very good activity. This is part 1 of the activity where we're going to show you how to do this all locally with Docker. And then in the part 2 video, we'll show you how to do this server side with EC2 and Docker, which is a little bit more complicated, but I hope I listed it out fairly simply in the wiki. So we'll go back over here to the wiki. The first thing, once we have all of our requirements installed, Python, Docker, VS Code, and Git, we're going to want to clone the code base and run it locally. So I already have Docker running this image locally. So if I do that command docker ps, I could see it here. I also have this code base saved locally. So if I were to want to shut down this Docker instance, what I would do is run a command called docker compose down. And what this will do essentially is shut down all of the containers that are used in this image and start it up with this image with Docker Compose. You can see they're all removed successfully. And then if I run this docker ps command again, nothing should print out, which is a good thing. Now, because I have the code base already installed here, what I'll do is I'll delete it and pretend as if I were you. I also have a root folder directory. I have it just called orangutan_stem_ projects. So if I wanted to remove that repository that I had cloned locally, I can just run this command sudo, which stands for superuserdo, rm, which stands for remove, and then -r, which stands for recursive, and then orangutan-stem projects. And what this will do is basically prompt me for my password, which I will enter. And then if I were to run ls again, I could see that this directory where I had the code base cloned into is no longer there. So I am hopefully exactly at the same steps as you, minus a few other things I have to do quickly because I had some volumes and images for this Docker build already saved on my local machine. So I'm just going to clear everything. There should be no containers, but I'm just going to clear all the images and volumes. Containers are empty, that's good. So this is basically as if I were a fresh user just like you cloning this for the first time, and I am right there with you in the steps. So let's follow the steps in the wiki. All right, so the first thing we're going to want to do is make a directory called orangutan_stem_projects. So I'll just type mkdir for make directory, orangutan-stem _ projects. This is just a root project directory, as I said earlier, so we can clone multiple code bases into here if we want and just have an easy place to access them so they're not scrambled all over our machines. So the next thing they're telling us to do is change our directory into orangutan-stem _ projects. So I'll just do the cd command. You can just start typing OR and then click tab to autocomplete if you don't know already how to do that. So once I'm in here, I'll just see it's an empty directory, nothing will print with ls, and then I'll actually run the command to clone the code base. So to do this, I can either just copy and paste it from the wiki itself and click paste, and if I click ls again or type ls again, I should see the orangutan-stem repo that was just cloned successfully into there, and we are good to start running Docker locally. So once the code base is cloned, we're going to cd into orangutan-stem, which is the repo we just cloned. We'll see if we type ls, we have a couple directories and a couple files. So we have the readme, Airflow directory, pipelines directory, docs, which is a directory, and then requirements.txt. We want to cd into orangutan-stem / Airflow. So if I were to start these steps over again, I would just cd orangutan-stem projects, orangutan-stem Airflow, just so I'm in the Airflow directory, and that's where we want to see this docker compose.yaml file. Once we see that file in our Airflow directory, we could run the docker-compose up command, which will start up our Docker instance. So let's go ahead and do that. This usually takes about 30 to 45 seconds when you're doing it for the first time. It's got to pull a bunch of containers from the Docker Hub registry. So it's pulling all these different layers of different containers that are going to be utilized in the application or the instance of Docker. We have the Postgres metadata database, the Airflow web server, where we actually see the UI on our browser. We have the initialization container, which boots up for the first time that we're creating this Docker instance. We have the workers, and then which actually execute task out, and then we have the trigger, which actually initiates task to start running. So the scheduler is basically how our pipelines run on an interval or whatever cadence. So Airflow is a data orchestration platform. It's very batch-based. There's two types of pipelines. There's batch-based pipelines and streaming pipelines. Batch-based, this might be a strong opinion, but 70 to 80% of the time a batch-based pipeline will accomplish whatever the business wants. So Airflow is a really popular and great tool because it's open source, it's easy, it's batch-based, and you can develop pipelines quickly in it. So this is all done now. We should start seeing some logs that are indicating this get health HTTP, and then this 200, which indicates a success. So if I go back into localhost 8080, refresh the browser because when I ran Docker Compose down, it shut down the web server. I'll type in username Airflow, and I'll type in password Airflow. This is by default in the Docker Compose YAML file, so we could change the password for this fairly easily. I'll show this in part 2 when we set up the EC2 server for this Airflow Docker build. So once we log in, we'll see a red banner that says DAG imports error. If we click into it, we'll see key error, variable open weather API key does not exist. So this is okay. If I go back to the wiki, it tells you what to do here. So basically we just have to create a new variable for it. So we'll go into admin, and then we'll go into variables, and then we'll click this blue button right here and then create a key called open weather API key. So to do this, we can just hit that blue button, as I said, type open _weather _API _key, and then the value is what we're actually going to retrieve from the open weather map API key section. So this section right here. As I said earlier, there's a snippet of code up here to test if your API key is ready to go. So the DAG will run end to end. So if you open up just a local IDE, I'll use PyCharm here. We are going to see in line 9 that we have to still put our API key inside of here. Otherwise, if we try to run this as is, likely nothing will happen. So I'll just start up a new Python console just to prove so. Real quick here. And as you can see, this is the type of error we might see if we don't have an API key or our API key is not yet valid. So if we want to make our API or check our API key is and whether or not it's valid. What we can do is we can just copy and paste the API key that we have from the Open Weather Map API API key section. None of these keys will be active after publishing this video, so don't try to copy and paste it. Please create your own account and create your own keys. I don't want to get my account suspended, so I can't use it for our farm in Sumatra. So once we do have our key, I could paste it into here, into the script that I have just as an open Scratch Python file in my local IDE on PyCharm. If I run it, I should see a response return like this, which shows us all the main weather content relevant to Pahoric, northern Sumatra, which is very close to Buka Lawang. So that's looking good. Our Open Weather API key looks like it's going to work. So I will go ahead and paste this value into our Airflow variable here. I'll click Save. And when I go back into the Airflow homepage, give it about 30 to 60 seconds. Airflow runs on this concept called heartbeats. So basically it's just, checking DAGs for updates, it's checking variables for updates, connections, plugins, all these different components that could be modified in Airflow when you're doing general development tasks. Heartbeats basically refresh all the information in the metadata database that all this stuff is stored in, as well as just all the necessary root paths and files where everything is written to in Airflow. So after that 30 to 60 seconds, you should see this DAG appear. I can click into it. I already went over a demo of what the DAG does, so I won't go too much into detail on this, but if we go back into the wiki here, into the section that we were at, which is to start creating our connections, because if we try to click running the DAG, it's not going to work. So just to prove this, I can just turn the DAG on, and if I refresh, it will either kick off automatically if it's past the hour that it was supposed to run, or if we're at a weird time of the DAG's scheduler, it won't initiate without you clicking play, which you can do this trigger DAG button right here. So as it says in the wiki, it won't pass. We have to set up our AWS default connection ID, as well as our Google Cloud Storage and BigQuery connection IDs. This is fairly straightforward, and I have some pretty detailed documentation here. I'll put some more screenshots and just in terms of all the required fields that you're going to need. So the first one we'll test is creating this AWS default connection. Connections are basically the way of how Airflow handles integration. So it's probably one of the best data orchestration tools in terms of integration that I've worked with. Worked with Prefect, I've worked with a few other SaaS tools that do it, but they're not as simple and just out of the box as Airflow. So if I click admin connections, I will be prompted to a new screen where I will see no connections, because I'm just starting this Docker instance for the first time, and no connections are stored anywhere in the instance in the volume. So if I want to add a connection, I'll just click this blue plus sign here. I'll type AWS_default. Please type it one-to-one just as it is in the wiki, otherwise this code won't work, since these connection IDs are coded into the DAG and into the default custom operator that's written for this DAG to run. So connection type, there's tons of different connection types. As I said, Airflow has tons of integrations just out of the box. You can add a description here if you want. So just, AWS connection for, reading and writing from S3. And we'll be prompted to put our AWS access key ID and our AWS secret access key here. So I'm going to go ahead and pause the video real quick just so you guys don't bill my AWS account. And I will click save right before I come back. So I will be right back. All right, I'm back. So once you've created the AWS default connection ID, be sure to add your access key and your secret access key that you get from your IAM account once you've successfully created a root user and an IAM user affiliated to that root user. You should get a CSV file that you're able to download when you create your IAM account, that you'll see that access key and secret access key that you can just simply copy and paste into there. So we have this connection ID set up. Let's go back into the wiki. Be sure to create a bucket called Orangutan Orchard in AWS. So if I go back in AWS here, where I had the data right out, and when I gave the demo of the DAG, be sure to create a bucket called orangutan-orchard. Again, this is coded into the DAG, into the plugins. You can modify this code and create your own buckets. Again, this code base is designed to be very flexible, but if you want to have this example work end to end, be sure to create this bucket in AWS S3. you'll also have to do the same in Google Cloud Storage. I'm not going to delete the bucket in the video. It takes a few minutes for the bucket to delete from the global settings of AWS and then allow me to create a new one. So just for the sake of time, I won't do this step. And we will go back into the wiki. Looks like everything is set up. We created our connection ID. We created our bucket in S3. All of our connection for AWS looks good. So the next one we're going to want to create is BigQuery. So we'll go back into Airflow. We can just click this blue button again. We'll type BigQuery _ default as our connection ID. Now, Airflow has a just BigQuery connection type. I like to just use the Google Cloud one. It's a little bit easier because I prefer using the key file JSON as the way of authenticating the connection. So just a recommendation from my perspective. So we'll also want to do another thing where we enter our GCP project ID. If we go into Google Cloud here, our project IDs could be found right up here. Be sure to do this one-to-one. Again, this is all coded into the DAG, into the plugins. You can modify this code and set it up as an inputted parameter if you want and make it really fancy, but just trying to show for the sake of the demo of how all this works, just so it's really cookie cutter and there's a comprehensive understanding of how it's done versus customizing it for your own use case. So be sure the project ID is exactly named this way. You'll see it in your GCP project console, and when you create your new project, just make sure to name it that way in GCP. So we'll go back into our wiki here. We're going to want to add some scopes, and this is basically API scopes that the integration or the connection ID that we're setting up to BigQuery will authenticate from the APIs that it's allowed to utilize. So this cloud platform and this BigQuery one are necessary for this connection to work. So we'll go back into the connection. We'll paste these right into here, and we'll also insert our project ID. As I was saying, be sure to have it exactly as Orangutan Orchard. In the code itself, that's how it's written, because it goes project ID.dataset.table name. And then the key file JSON is the actual service account JSON key that you'll get. So to generate these is pretty simple. You can just go into IAM admin on GCP, and then there's a section called service accounts. You'll want to create a service account here. Be sure to affiliate all the correct permissions around it. So I have all these listed in the requirements wiki. You'll want to make sure you have all the BigQuery and Google Cloud Storage necessary permissions. And when you have your service account created and you can click into it, you'll go into the key section, create add key, and then you'll want to do it as the JSON. And once you have this JSON, you'll basically copy and paste the content into it directly into the Airflow connection page. So I have this already available locally. So what I'll do is I will open it and we will paste it directly into here. It's a pretty big file because there's a private key in there that takes up a lot of characters, but this will still work. Just don't add any extra spaces to it, and make sure that both the beginning bracket and the end bracket of the JSON are in whatever you paste into this. So this looks good. We have our connection ID name, the connection type, our project ID, our key file JSON, and our scopes. I'll click save, and then we'll create our final connection ID that the wiki has us do, which is called Google Cloud Default. So in Airflow, we'll click add a new connection, call this connection ID Google _ Cloud _ default. We'll use the same connection type we used for BigQuery called Google Cloud, same project ID, and then the same key file JSON that we had pasted from that service account. And if you wanted to use a different service account and you wanted to keep the same connection ID, it's pretty simple. I will show you that here in a second, but let's first copy and paste the scopes into the connection itself so that they're there. We only need one for this one. If we ever add some other scopes, like for different APIs Google's offers, such as Sheets, Drive, Maps, all that stuff, we could just comma separated, no spaces for each scope. So pretty straightforward. We'll click save on this one. And as I was saying, if you ever wanted to update your service account JSON key. It's really easy to do. You'll just go back into edit the connection. You'll just paste the new key into there, and that's it. Click save, and it's all there. So if we go back into the DAG and then try running it, hopefully this all runs end to end as designed. There's one thing I kind of brushed over in the wiki, which is creating the table in BigQuery, but it's pretty straightforward. I'll show you how to do that here in a second when we check the results. So this is running, everything ran successfully. That's wonderful. We'll go back in the GCP and we'll go into BigQuery, and we have to create a data set called Bukit_Lawang_weather. And under that data set, we'll have to create a table called raw_ingested_main_weather_content. In here, we don't actually have to create a schema with it. We just have to create a blank table. So if you want to create a new data set, you just click this ellipse right here, create data set. You add a name to it. You can just use multi-region by default. Just don't run a bunch of compute and a bunch of crazy big data ops in there, and your GCP budget won't suffer. And then once you've created that data set, under the ellipse of when the data set appears, you'll click this create table, and then be sure that the appropriate data set is assigned to it as you click the ellipse from that row, and then you'll want to assign the correct table name, which I believe here is raw ingested weather data. So just do it as it's designed in the wiki, and it should be good. If I delete this table right now and then I try rerunning it again from Airflow, it should still work, because if I go into the code section here, I have the actual schema hard-coded into the DAG to just show you how BigQuery schemas are set up. I'll have a part 3 to this video to this activity that goes into more detail on all the different components to this pipeline, the DAG, the custom operators, and all the connections. But if I go back into BigQuery here and open up this table, or open up this data set, I believe, which I'll probably have to refresh my browser real quick. I'll see that the details, it was just most recently refreshed and run. And then if I go into the preview, I'll see the record that I just run for it. So all of this looks good and just as designed. And yeah, in the next part, I will be showing you guys how to set this all up server side on EC2 and point the Airflow web server to a public IP and domain DNS record, so that you could actually just go into a browser, type something like airflow.orangutan-stem.com, and you could run this all server side, so that it's not running on your local machine, so it doesn't fail to run whenever your computer's shut or asleep or not operational, or catches on fire. So this is the end of part 1 of the first video. Hopefully you made it all the way to here and you were able to successfully create this Airflow Docker environment on your local machine. In the next part, I will be showing you how to do it in the EC2 server. All right, have a good rest of your day and look forward to seeing you in part 2.